My name is Purkait, Assistant Professor of Swami Institute of Science and Technology. Today we are going to discuss a topic which is improper integral. First of all, we will start about what is the difference between a definite integral and improper integral. What is the difference between definite integral and improper integral? Let us take an example. Let integration 0 to 1 dx by x. This integral actually a definite integral. It is definite because it has lower limit as well as upper limit. But this integral actually an improper integral. This integral actually an improper integral. Why? Because if we put here our function fx is 1 by x. Okay? Now the lower limit is 0 and upper limit is 1. And if we put x equal to 0 means the lower limit in place of our function, then we get 1 by 0 which is undefined. So if we get any undefined value for lower limit or upper limit or any point between lower limit and upper limit, that integral is called improper integral. So this integral, in spite of this integral, has lower limit, upper limit, but this integral is not definite. This is improper integral since at the point of that lower limit, the integral has the function has infinite value. So if we get any infinite value of the function of any our point at lower limit or upper limit, then the integral is called improper integral. Okay, let us take another example. Let integration 0 to 2 dx by x into x minus 2. Here our function fx is 1 by x into x minus 2. Here if we put the lower limit 0 in place of this x, this will be infinite. Or if we put our upper limit 2 in place of this x, if we get again 0, 1 by 0 is infinite. So in place of x, if we put our lower limit or our upper limit, we get the function has infinite value. So this integral is also improper integral. Otherwise, if we take this example 0 to 3 dx by x minus 2. Here we can see that our function fx is 1 by x minus 2. Now the lower limit is 0. If we put 0 here, no infinite value. If we put 3 here, no infinite value. But in between 0 and 3, there is a point 2. And if we put 2 here, this will get infinite value. So in between lower limit and upper limit, if we put any point where the function has infinite value, this integral is also improper integral. And that point is called point of infinity. That point is called point of infinity or singular point or infinite discontinuity So improper integral means if the integral has any point of infinity or singular point where the function has infinite value, the integral is called improper. Okay, let us take another example. Suppose the integral is minus infinite to infinite dx by x. There is no finite limit. The limits are infinite. If we get any limit of the integration is infinite, that integration is directly improper. Again, if we put 0 to infinite dx by x, this is also improper. Without any checking, we can say that this is improper because the upper limit is infinite. If we put minus infinite to 0 dx by x, this is also improper because the lower limit is infinite. So if we get any lower limit and upper limit are infinite, then this is directly improper. And if the limits are finite, suppose 0 to 2 dx by x x into x minus 2. Their limit is finite, there is no infinite, but this is also improper because 0 or 2 are points of infinite or singular point. Okay, now how to solve this type of improper integral? Let us take an example, integration 0 to infinite dx by 1 plus x into root x. Suppose this is improper because the upper limit is infinite. Now we have to write limit capital X suppose tends to infinite, integration 0 to capital X dx by 1 plus x into root x. Okay, so this capital X is any finite value, so we replace our infinite value by a finite number, and now this integration, we have to solve this integration, and at last we put the value of x which is infinite. Now for solving this integration, we take root x equal to suppose z square, then x equal to root x is equal to z. Root x is equal to z, so x is equal to z square and dx equal to 2z dz. Now if we put this integration without any limit, dx by 1 plus x, dx by 1 plus x into root x. So value of dx is 2z dz divided by 1 plus x means 1 plus z square into root x means z. Okay, so z cancel, 2 into integration dz by 1 plus z square. Now we know the direct formula of this integration dz by 1 plus z square is tan inverse z. So the value of this integration becomes tan inverse z, and we know the value of z is root x. So finally 2 tan inverse into root x. Now we put the limit 0 to capital X. Now we put the limit 0 to capital X. So that will be 2 tan inverse root capital X minus 2 tan inverse root 0. Now we know tan inverse 0 is 0, so that is only 2 tan inverse root x. Now what is the value of capital X? Capital X tends to infinite. So last we put that 2 tan inverse in place of capital X is infinite, and we know tan inverse infinite is tan pi by 2. The infinite value of tan is tan pi by 2. Now 2 tan inverse tan pi by 2 will be 2 into pi by 2. 2 cancel. The value of the integration is pi. So in this way we can solve any improper integral by taking the infinite value replaced by a finite number. Then similar way we can solve the integration. Last we put the value of our infinite number